So let's have another example for your source transformation. Okay, so find for the value of ix using source transformation in this circuit. So number two, so find the value of ix. Okay, how we will solve this one? So we have the circuit diagram will be positive, negative, 60 volts, and then a 15 ohm resistor and another 50 ohm resistor and a dependent current source is a current dependent current source 0.5 ix, and then we have a 40 ohm resistor and then another 10 ohm resistor, 10 ohm resistor. Okay, so this is your ix. The question is that we'll find for the value of ix using source transformation. So how we will do this one? So we have a value of 10 ohm and 10 ohm, 40 ohm, 15 ohm, 50 ohm resistances. So the basic thing to do is that huwag natin gagalawin tong loop na tong mesh na to. So therefore we will be simplifying on the other side of the circuit, so probably this side. Okay, so how we will simplify this one? Take note that your 10 ohm is in parallel with a current source, so therefore I may say that it can be rewritten into a voltage source. So we have our V is equal to I multiplied by our R. Take note that our R that is in parallel with this current source is your 10 ohm, and then your I is basically equal to 0.5 ix. Therefore this voltage will be equal to 0.5 ix multiplied by 10. So therefore we have a 5 ix voltage. Okay, so we have a voltage source. So anong gagawin natin? Magiging series lang yan. So therefore we will have a new circuit diagram. So we will have positive, negative, 60 volts, and then a 15 ohm resistor, and then take note this is a 50 ohm resistor, and the series combination of your 10 ohm and your 0.5 ix current source, current dependent current source. So magiging voltage dependent voltage source. Take note of the direction of the arrow, so therefore this is positive and this is negative, and then we will have a series resistance 10 ohm, kasi nga itong ang gagawin natin is at parang itatanggalin natin to and then ibabalik natin. Okay, so pag tinanggal mo yan parang kakalas yan, so parang kakalasin natin yan and then ibabalik natin siya with this terminal already. So parang tatanggalin mo yan, yun yung rationale niya. Okay, so para magiging ganito siya. Okay, and then this is a 10 ohm resistor, and then gagawin natin siyang ganito, positive, negative, 5 ix in series with a 10 ohm resistor, and then ibabalik natin siya sa tinanggal nating terminal. So magiging ganyan siya, and then we will have a 40 ohm resistor. Okay, okay, so you will notice that this it's 10 ohm and 40 ohm is already in parallel condition. So series condition. So therefore I may say that it can be your positive and negative 60. So we have 15 ohms, and then another 50 ohms, and then your dependent voltage current dependent voltage source. So 40 plus 10, we have 50 ohms. Okay, so mapapansin mo nakakalasin na naman natin itong terminal na to. Okay, so we will have this terminal again. So positive, negative, 60, and then we have 50 ohms, and then yung kinalas natin, so we have our 50 ohms. Okay, so mapapansin mo yung kinalas nating diagram is ibabalik natin mamaya. Yan, so kakalasin natin yan. So we have your negative, positive 5ix and your 50 ohm resistor will transform it into its equivalent current source transformation. So therefore ix I is equal to V over R, wherein our V is equal to 5ix and our R is equal to 50 ohms. So therefore our I is equal to 5 divided by 50. We have 0.1 ix. 0.1 ix. So upon noticing that it is 0.1 ix, so therefore I may say that since positive negative yan, saan natin ilalagay yung arrow mo? So our arrow will be like this one. Okay, so pababa. Okay, our arrow will be like this. So susundin natin yung ng arrow mo, kasi kahit linipat ko to dito, so pababa talaga yung arrow natin, kasi pag linipat natin tong current source dito sa bandang to, magiging ito siya. So 50 ohm. So ito yung current source natin, itong voltage source natin, positive, negative, and this is your 50 ohm. Mapapansin mo na pababa dito yung direction ng current natin. So therefore this is equal to 0.1 ix in parallel with our 50 ohm resistor. Okay, 50 ohm resistor. So ito yung magiging bagong terminal natin na ikakabit natin dito sa terminal na to. Okay, so we'll have another 50 ohm resistor and a 0.1 ix source. Yan, 0.1 ix. Okay, so i-write ko para mas makita kasi ang pangit. So we have positive, negative, 60 volts, and then a 15 ohm resistor and a 50 ohm resistor from the original circuit. Take note that this is my ix, and then we have another 50 ohm resistor from our source transformed circuit. So 50 ohm resistor and our 0.1 ix going down. Yan, 0.1 ix. Okay, so take note that you will see that your 50 ohm resistor is in parallel with 50 ohm resistor. So we will have the parallel combination of 50-50 is just equal to 1 all over 50 raised to negative 1 plus 50 raised to negative 1, it is equal to 25 ohms. So, gaya ng shortcut na sinabi ko, R value divided by 2 or N, wherein N is a number of resistor. Pag RV1 is equal to RV2, which is 50 over 2, which is equal to 25 ohms. So, kaya lang yung shortcut yan. So, since you already have a 25 ohm resistor, so let's rewrite the circuit. Ang mahirap lang kasi dito is that you will write a lot of circuit, but it is after writing the circuit into a very simple circuit, it is very satisfying. But the problem is that, how about if you will have a circuit that is more complex than this one? Okay lang to kasi nga meron tayong mga circuit na pwedeng mga resistor that are directly parallel in series with a voltage or current source. How about if nothing? So therefore, the source transformation will be useless. Okay? But if there may pagkakataon, if there will be a chance, okay, that you might use your source transformation to make the circuit easier to analyze, therefore, go for it, because that is the main reason of this lecture. So 0.1 ix. Okay? So another thing, so you can see that this is also again a source transform can be used to have our source transformation. So we'll have, so tatanggalin ulit natin yan. So we have positive, negative 60 volts. So 60 volts yan. And then our 15 ohm resistor. So tatanggalin natin siya in order to make it into a voltage transform. So wherein our V is equal to our IR, wherein our I is equal to 0.1 Ix and our R is equal to 25 ohm. So therefore we have 25 multiplied by 0.1 Ix, we have 2.5 Ix for the value of our V transformation, voltage transformation. So therefore we have a series connection of your resistor, which is 25 ohm, and then its voltage transformation. So take note of the direction of your current. So negative, positive. So bababa kasi yung ulo niya. So we multiply, so this will be our voltage transformation. So ibabalik natin siya dito. So we have yung mga terminal siya, saksak natin siya ulit. So we have 25 ohm, and then your negative, positive 2.5 Ix. Take note that our Ix is this Ix, or the current at your 15 ohms. But since after source transformation you have a series combination of your 15 and 25, therefore the current at Ix, or current at 15, is equal to the current of 25. Take note that our I total is also equal to Ix, which is also equal to I15, which is also equal to I25, because it is already in series. Since naka-series na yan, so pwede nating sabihin that your I total is equal to Ix, which is also equal to I15 and equal to your I25. Okay, the best thing to do is using your KVL. We have KVL at loop 1. So we have our negative 60 plus our 15 plus 25 multiplied by our Ix, so minus your voltage source, which is equal to 2.5 Ix minus 2.5 Ix. Okay, so therefore we will have a value equal to 25 plus 15 is 40 minus 2.5, we have 37.5 Ix. So transporting your 60, so this will be your 60. So solving for your Ix, we have 60 divided by 37.5. We will have a value equal to 60 divided by 37.5. We will have a value equal to 1.6 ampere. So this will be the answer of your Ix. Okay. Very easy, right? Very easy. First thing to it is all about your imagination. Imagination with concrete use of the manipulation of the circuit diagram using your source transformation theories or theorems. Pag nagkamali kayo ng isang theorem, like yung napagbaliktad nyo yung ulo ng current nyo, therefore, that would be very disastrous to the equation. Okay? So, the answer will be 1.6 ampere.